I'm Anil Kumar. Welcome to part 2 of calculus derivatives. We have taken up this function f of x equals to x to the power of 1 over 3 times x plus 3 to the power of 2 over 3, and we'll try to understand all about derivatives of calculus with this example. In part 1, we basically learned about the characteristics, right? And without using any concept of derivatives or calculus, just by our knowledge of functions, we were in a position to predict the graph of this function, and it looked kind of like this. So I'm just sketching what we did in part 1, right? So it kind of looked like this. Now we have to see how well did we make that prediction. We also predicted these points. This was minus 3 and that is 0, right? So that is what we did in part 1. Basically, from the characteristics, you find the x-intercepts. There are two x-intercepts. One is at 0. The other one is at minus 3, right? So these are the two x-intercepts. We also found when is this graph positive. This portion x plus 3 is always positive because of 2, and this portion is positive when x is positive. So when x is positive, the graph is always positive, but when x is negative, graph is always negative. Now since we have these two zeros, the graph would cross the line or may not cross the line at the 0. Now since it is negative, it cannot cross, so it bounces back. At this point, it has to cross. Now how did we get these two ends? We got these two ends from end behavior. So if x is very large negative value, the function will be large negative value. If x is large positive value, the function will be positive large values. From end behavior, we got these two, and so thereby, and also domain is all real numbers, no restriction, a continuous graph. This kind of function means you can expect a cusp, which is right there. So all this combined together straight away gives us the graph. The idea of these set of 4 videos is to analyze, apply all what we've learned in derivatives, and then sketch an accurate graph, which we are going to do step by step. So here we'll do the first derivative of the given function, and we'll analyze this derivative to find a couple of things. As you know, we'll find increasing interval, we'll find decreasing interval, and we'll find maximum and minimum value, right? So minimum, let me write maximum, correct? So increasing interval is when the derivative f dash x is greater than 0. Decreasing interval is when the derivative is less than 0. Maximum is when the derivative f of x changes from positive to negative, so I'm not writing much, and this is when the derivative changes from negative to positive. Is it okay? So that is how we are going to answer all these questions in this particular video, right? So let's begin by finding the derivative of the given function, right? So the function here is f of x equals to x to the power of 1 over 3 times x plus 3 to the power of 2 over 3. Now here we should apply the product rule to find the derivative. So f dash x is equals to derivative of the first function, which is 1 over 3 x to the power of 1 over 3 minus 1, which is minus 2 over 3, times the second function, right, plus derivative of the second function and the first function, right? So the derivative of the second function is 2 over 3 x plus 3 to the power of this minus 1 gives us minus 1 over 3 times the first function, which is x to the power of 1 over 3, correct? Now the trick part here is actually to factor these out and simplify. So that's a big thing. So we'll also understand the strategy of simplifying such a radical function, right? Now what we do here is we try to take whatever is common. So 1 over 3 is common, okay. As far as x is concerned, we have x to the power of 1 over 3 and x to the power minus 2 over 3. Minus 2 over 3 is lower, so we'll take that common. The other factor is x plus 3. Now in these two terms, x plus 3 to the power of minus 1 over 3 could be taken common, right? Once we do that, what remains here is we have already taken 1 over 3, we have taken this term, and from this term, if I take away that much, then what is left? So it is 2 over 3 plus 1 over 3, that is just x plus 3. So x plus 3, and here we have 2 here. We have already taken up this term, we are left with this. When you add 2 over 3 here, we get 3 over 3, so we have 1, x to the power of 1, so 2x. Do you see that? So that is how you could simplify. Now negative powers means they will come in the denominator, right? So denominator. So we have 3 in the denominator, we have x to the power of 2 over 3 now, and we also have x plus 3 to the power of 1 over 3. In the numerator, you could simplify all this, right? What you get here is x plus 2x is 3x. So we get 3x plus 3, right? Now here you can take 3 common, cancel with this 3. So that gives you the derivative of this function. So let me write it here. It is 3 times, or okay, so we just take 3 common, right? So we take 3 common, we get x plus 1 in the numerator, and the denominator is, I have to push it a bit too so that you could see, right? So we have 3 times x to the power of 2 over 3 times x plus 3 to the power of 1 over 3. Now these 3's, they cancel off, right? So once they cancel off, then we could write this as, let me write big and bold, right? So yeah, so I'll write it here, right? So we have x plus 1 here, and then we have x to the power of 2 over 3 times x plus 3 to the power of 1 over 3. Is that clear? So after simplification, we get all this. Okay, now we'll use this half of the page to analyze the derivative. Okay, now since we have this derivative, we know where are its zeros and where is it undefined, correct? So those are the points which we need to figure out. So first, let's find the critical numbers. Okay, to find critical numbers, what do? We say, well, we need to figure out that the derivative f dash x equals to 0. That is at x equals to minus 1. And then also when the derivative is undefined, so it does not exist, right? So in that case, denominator is 0, so that gives us two values, x equals to 0 and x equals to minus 3. Do you see that? So we have these 3 critical points. Now we'll analyze these 3 critical points and then see whether we have a maximum or a minimum or not, correct? So to analyze these points, let me make a table where we'll have intervals and then we'll analyze the intervals. So that's the whole idea, right? So we'll write the terms here on this side, and then we'll write, so we have 1, 2, 3 points. So let me make 1 point here, second, third, okay. So that should work anyway. So what we will do here is we'll write in kind of order, minus 3, x equals to minus 3, x equals to minus 1, and x equals to 0. These are the 3 points which we are going to analyze. And we'll take test points and these intervals. It could be minus 4. These are the test points for us. In this interval, minus 2, 0.5 negative. And in this interval, we'll take 1 as the point, correct? Okay, so let me just close this also. The factors which we are interested are x plus 1. So we'll see what happens to x plus 1, what happens to x to the power of 2 over 3, and what happens to x plus 3 to the power of 1 over 3 at these test points. We don't want their values, we only want whether they are positive or negative, right? So if I substitute minus 1, minus 4 in this, it is negative, minus 2 in this, negative, minus 0.5 will make it positive, this will be positive in this interval. This is from 0 to infinity, right? X to the power of 2 over 3 will always be positive. That square thing makes it positive. X plus 3 to the power of 1 over 3. Now, if x plus 3 is negative, it is negative. If x plus 3 is positive, it is positive. So for minus 4, this is negative. For minus 2, it is positive, so it's positive thereafter, correct? So we have all this. Now when you multiply, or when you have product and sum, I mean divide or multiply, then the derivative will be 2 negatives will give us positive, right? So 2 negatives gives us positive, 1 negative is negative, 3 positives is positive, 3 positive is positive. Now what does that suggest? This is the analysis of first derivative, f dash x, x prime, x whatever you say. Now when it is positive, it means that in this interval, the function is increasing, right? So the function is increasing. When it is negative, it means it is decreasing. Positive means increasing. Positive means increasing, correct? So that clearly indicates that we do have a maximum and a minimum, right? So this point here is the maximum. So let me write down max here. And this point here is minimum, right? So this is minimum. So what we have here is maximum at x equals to 3, minus 3, I mean. X equals to minus 3 is maximum, and at x equals to minus 1, we have a minimum, correct? So let me just push this a bit here. So now we can find what is maximum and what is minimum. So we know now that maximum value is at x equals to minus 3, right? So that is the maximum value. So this is at minus 3, and the minimum value is at minus 1, right? So what you can do is substitute these values. So if you substitute minus 3, that factor becomes 0. So we get this as 0. Do you see that? So this point looks like a maximum. It is indeed a maximum from this calculation, right? So that prediction is fairly good for us. Now minus 1 is a minimum. So we'll say this point is actually at minus 1. Now we need to find its value, right? So let's substitute minus 1 here. So what is the value of f of minus 1? So minus 1 cube root is minus 1. And then if I write minus 1 here, I get minus 1 plus 3 to the power of 2 over 3, right? So that is equal to, it's definitely negative since this is negative. This is 2 squared 3, that is cube root of 4, right? So that is what it is. So we can just calculate this value in decimals and figure it out. Cube root of 4 is what we're looking for. So 4 to the power of 1 by 3. So 1 divided by 3. So that is what we're looking for, right? So it is 1 point, so let's say minus 1.58. So we'll write this value here as minus 1.58. Is that okay? So that is how we can find the minimum analyzing the first derivative, right? So it's cube root of 4 minus, which is the exact value. Perfect. So in this video, we learned that we could find the first derivative and then find maximum, minimum, increasing, decreasing intervals. So let me write down what is the increasing interval here. As you can see, it is increasing from minus infinity to minus 3, and then it increases from this point minus 1 to 0, and then from 0 to infinity, right? So it keeps increasing, and you can see that it is increasing in these intervals, right? So the increasing interval for us is from minus infinity to, okay, I just messed it up. Anyway, so let me write down here, increasing. So I'll say it increases from minus infinity to minus 3, right? And then again, it increases from minus 1 to infinity, right? So that is the increasing interval, and it decreases in the interval, in this interval, minus 3 to minus 1. So it is from minus 3 to minus 1. Is that okay? So that is how we can actually summarize our learnings from part 2. Now we'll move on to part 3, where I analyze the second derivative, and by doing so, we'll know what. So in part 3, we will do second derivative, and that will give us concavity, right? Two things, concavity and point of inflection, right? And then in part 4, we'll sketch this function. I'm Anil Kumar, and I hope it was a good review for you. You can always share and subscribe my videos. Put some likes if you like. Thank you, and all the best.